Draw a picture of the situation, label the forces acting on the boat, and set up Newton's second law. Okay. So, here is the ocean. Here's a crane. Whoop. And here's the big ship. I don't know, it's a submarine. I don't know what this is. Let's make it into an actual boat. There we go. There we go. All right, yeah. So, label the forces. All right, forces acting on said boat. There is always gravity down, so I'm going to draw it. There is always buoyant force up, so I'm going to draw it. And now there is an applied force up, or a lift force up, or even if you called it a normal, I wouldn't take it off. That's not right, but I wouldn't take off points for it. I'm just going to call it an applied force. So, Newton's second law, F net equals MA. So, F net equals MA. So, what is the F net? It's all the forces up minus all the forces down. So, the up forces are applied plus buoyant. The down forces are gravity equals MA. Bam. And let's go ahead and plug in the numbers that we can. Do we know how much force the crane applies? No, so I just write FA. Do I know how much the buoyant force is? No, so I just write FB. Minus FG. Do I know that? No, but I can find it. FG equals MG, so it's 18,000 times 9.8. Okay? Equals MA. So M is 18,000. And A is 0 because, unless I tell you, it's 0. It doesn't say, so it's 0.
Will it, like, say in the problem? Like,
Yes. For example, botrydinium is accelerating at a rate of 0.05. So it will tell you specifically if there is one. Okay? So, find the buoyant force acting on the boat. So, I can't find it using this equation, so I need to use a different one. I have two equations for buoyancy. This one, that one. Do I know the mass of the fluid? No. Again, it's the mass of the fluid pushed out of the way by the submerged boat. I don't know what that is. It's not the mass of the ocean. You'll have to find the mass of the ocean. Okay? It's the mass of the submerged boat, because that's how much fluid is pushed out of the way by that. Okay? All right. So that's not going to work. But this one will. Buoyant force equals density of the fluid. I know it. Mass of the object. I know it. Density of the object. I know it. Gravity. I know what that is. So that's the equation to use here. Okay, so 1,025 times the mass of the boat, 18,000, divided by the density of the boat, which is 7,800 times 9.8. So it's just a matter of plugging in all the math here. 1,025 times 18,000 divided by 7,800 times 9.8 gives me 23,180.8. C, use Newton's second law to solve for the lift force. Okay, here's Newton's second law. It's already set up. Let's plug in my number for FB and solve for the applied force. So FA plus the buoyant force, 23,180.8, minus gravity, so 18,000 times 9.8, 176,400 equals 0. So when I solve for FA, 23,180.8 minus 176,400, add that to the other side. We get the applied force is 153,219.2 newtons. Okay? Those are the two basic types of buoyancy. Well, three. The third one is the floating problems we did last lab. Okay? So those are the three types of buoyancy problems you can see. Now, I have very good news for you. Ready? You're not ready. But I'm going to tell you anyway. These are the last hard problems we're going to do this semester. I imagine. I think they are. Maybe you will disagree with me, but I think if they're not the last hard problems, they are the hardest problems we have left for this semester. Because the next unit we're going to do is thermodynamics, and thermodynamics is another concept. But you get to set things on fire next unit. Yeah! That is kind of terrifying how excited you all got about setting things on fire. All right. What I'm passing out is bonus problems. Do you have to do them? No, they're bonus. Can you do them? Yes. Can you do them both? Yes, you can. You can get bonus for both of them. Do you have to do both to get the bonus? No, you don't. You can only do one if you'd like.
Get more bonus. You have to try.
Yes, you will get more bonus. Yes, you do have. Well, you have to put forth effort to get points. Yes. Okay. They don't have to be perfectly. They don't have to be perfectly right to get bonus. You can get partial credit bonus. You need to do more than just draw the picture and write some numbers down. Okay? You need to get a little further than that. I try to give you hints on these because these are hard, right? These are hard problems. One is a little bit easier than two. So number one, to thoroughly impress the ladies, Ilias applies a force of 1,100 newtons to a set of weights while submerged underwater. By accounting for the buoyant force acting on the steel weights, figure out how much mass he can lift. So the idea is this. You can lift a certain amount of weight out of water because your arms can apply a maximum amount of force, and that's how much weight you can lift. So if you can apply 400 pounds of force, you can lift 400 pounds. In the water, though, remember there's a buoyant force, which means you can actually lift more weights for the same amount of force because the buoyant force is going to help you. Okay? So maybe on land you can lift 400 pounds, but in the water you can lift 450 pounds. What you're trying to figure out is how much weight can you lift under the water? How much mass can you lift in the water? And I gave you some hints. If you think the answer is 112, you did it wrong. Okay? So if you solve and you're like, oh, it's 112, you can look at it, oh, it's not. Okay? There are three forces on the weight. Okay? Yep, so applied force is one of them. The acceleration on this problem is still 0. Okay? And there's a lot of substitution in this one. So you're going to want to set up Newton's second law, and then you're going to want to start plugging in like these equations, like plug in mg for fg, that kind of thing. Bonus 2. What volume of hot air is needed if a balloon is going to lift 180 kilograms, which includes the mass of the balloon and the mass of what's being lifted? So draw a diagram. You're going to need to solve for something before volume. So before you can find the volume, you're going to need to find something else about the hot air. And then the FG and FB do not have the same object. What I mean by that is FG is the weight of the balloon. So that's 180 times 9.8. But FB, when we're talking about the object for FB, the object is the hot air, not the balloon. Okay? So bonus 2 is harder than bonus 1. They're both difficult, hence the fact that they're bonus. So you can do them if you want. You don't have to. What I want you to do, though, the rest of the period, is work on finishing practice 2. Okay, but we've done a lot of, oh, did I leave this running the whole time? Of course I did. Excellent.